Okay, I think I am live. Can anyone confirm that in the chat box, please? Okay. Yeah, I think it is live now. Okay, I'll wait for 1 more minute. I think we can start now. Okay. So hello and welcome to this session. And स्वागत है आप सभी का आज के सेशन में. So this is for number system part 2. I hope you must have gone through the part 1 of this number system. So in the part 1, I discussed about classification of numbers, about how to calculate factors, even factors, odd factors, how to calculate sum of factors, sum of even factors, sum of odd factors, about HCF and LCM also. These things we have already discussed in part 1. Okay, so today is part 2, and in this session we will be discussing about remainders, right, and unit digit, last two digit, and about base system also. So I think because most of the things were covered already in the first part, so this is going to be a short session. Okay, so if everything is fine, I think we can just start with the session itself. Okay, so if you have any doubt regarding any slide or any question, we will be doing a lot of questions. So if you have any doubt regarding any question or anything, you can just put it in a live chat and I'll answer that. Okay, so let's start for today's session. Right, so before we begin, I have a few updates for you, starting with the WhatsApp channel. So we are sharing free preparation resources with you, and also if there are any important updates, so those all updates will be shared with you in this WhatsApp channel. So you can find the link for that in the description box of this video. So I will recommend you to join this WhatsApp group so that you can interact with the students who are also preparing for this exam, right? So I think this will be very beneficial for you if you're preparing for this exam, or maybe if you're preparing for IPMAT or any other exam also. So these preparation resources will be very helpful for you. Okay, so you can join that. Okay, and also like today's session is on number system. I don't think this is visible, but yes. So today's session is on number system. Tomorrow it will be trigonometry, then data interpretation and interest and stats. So you can see we are bringing so many free sessions for you. This is a free video series by Team Cracku. So if you are coming to this channel for the first time, then I will recommend you to subscribe to this channel so that you are not missing out on any session. Okay, so these sessions will be very helpful for you. Okay, yeah, and also there are free 5 mock tests that we are providing. All you need to do is just visit this cracku.in IIM Bangalore UG mock test, and you can attempt these mocks for free. Okay, you just need to register and you can click here and you will be able to attempt those mocks. So I think this will also be very helpful for you if you are preparing for this exam. This was the update. So now I think we can start with the session. Okay, yeah. So let's start with today's topic. That is, first is remainders. Okay, I think this, starting with the very basic concept about remainders, I think you should already know about it, but let me brief about it. So if we were to calculate, let's say 7 divided by 4. So how we used to do it during our school days? Just trying to explain it. Okay, so this is how we used to do that: 7 here, 4 here, and 4 into 1, that is 4, and the remainder comes out to be 3. So this is the basic calculation that we used to do during our school days, right? But I think this is pretty basic, so I should not waste a lot of time here. But what is more important is that concept of negative remainder. Okay, so let's take one more example here. Let's say I have to divide 19 by 7. Okay, doing the same thing, let's say, or I should avoid this calculation. So 7 into 2 is 14. So the remainder will be 19 minus 14, that is 5. So here the remainder is 3, and here the remainder is 5. Okay, so apart from this, there is a concept of negative remainder also. So the reason I wrote it here was to explain you the concept of negative remainder. So if I have to do the same calculation again. Let's say 4 here, I need to divide it by 7. Then instead of multiplying it by 1, if I can multiply it by 2, then it will give me 8. And if I minus, I will get minus 1 as the remainder. So if I am dividing 7 by 4, then either the remainder can be plus 3, or I can write the remainder as minus 1 also. Okay, these are the two possible remainders when I will be dividing 7 by 4. Same we can do this way with this calculation also. So if we are dividing 19 by 7, I can do it here for you. Let's say I'm dividing 19 by 7. So 7 into 3 is 21. So this will come out to be 2. That is minus 2, of course. Yeah, so or I can write if the remainder, if I'm dividing 19 by 7, so it can be either 5 or minus 2. Okay. So what is the purpose of writing negative remainder? So when we are just calculating the remainder, so this sometimes helps us in easing our calculation. So we'll look out in the next slide, we will look at how this helps us in easing our calculation. But right now, just try to understand that when we are dividing 7 by 4 or maybe any number with this remainder, so there are two possible remainders. One that we used to calculate like this in our school time, like this is the normal calculation. But apart from this, we can write the negative remainder also. One more thing you need to notice here is that the summation of the positive remainder and the negative remainder, just look at the magnitude, not the sign. So this will always be equal to, their sum will always be equal to this. That is 3 plus 1, just the magnitude, not the sign. So 3 plus 1 will be equal to 4. 5 plus 2 will be equal to 7. And also with this, with the help of this part that I did, what you will be able to calculate, let's say we don't know the numerator. There is one numerator n and we don't know the value of numerator. And if in the denominator it is 7 and I know that the remainder is 5. Let's say we are taking this case also, but we don't know the value of numerator, that is 19. And we know that the remainder is 5. So what we can do is, with the help of this calculation, because 3 is the quotient, so what we can write here is that n is equal to 7 multiplied by some constant, that is quotient, plus 5. Right? So because we don't know the value of n, so we can represent that with the in terms of denominator as well as the remainder. So 7 multiplied by with some constant plus remainder. So I think you can understand with the help of this example, when we did with the positive remainder, 7 into 2 is 14. So the remainder will be 5. So here in this case, the value of k will be 2. So 7 into 2 is 14 plus 5, 19. Or let's say if there is some larger number, so we can just substitute the value of k and we can get the value of n. So basically, if we don't know the value of n, we can just represent it in this form. So whatever will be the value of n, it will follow this form: 7 multiplied by with some constant plus 5. Okay. Okay, I think this should be clear. Now let's look at simplify the numerator and denominator. Okay. Right. Let's say if we have some calculations, if I have to multiply 189, just taking some random values, maybe 172, let's say I take 172, let's say 95 I'm taking, okay, I'm just taking some random values, and if I have to divide it by 25, okay, and I need to calculate what will be the remainder. Okay, I need to calculate what is the remainder. So first thing is, of course, you can multiply this and check it by dividing this by 25. But one more thing that you can do here is, because you know that 95 and 25 have one common multiple, that is 5, right? So you can just cancel out 5 from the denominator as well as the numerator, so that you are able to ease your calculation. Okay, now you need to just check the remainder with 5. But remember, whenever you are cancelling out any number from numerator and denominator, then you will have to multiply it with your end result. We'll see it. Okay. So now, with the help of, because we have cancelled out 5 from the numerator and denominator, we need to just check the remainder of these terms from 5. So 189 by 5, so I know that 185 will be divisible by 5, so 4 will be the remainder. So either I can write 4 or minus 1 also. Okay. So let's say I write -1. And from here also, because it is 172, I know that 170 will be divisible by 5. So I can write it, the remainder as 2. And from here also, I can write the remainder as either 4 or -1. So with the help of negative remainder, we have some small values to calculate, right? Otherwise, I will have to multiply 4 with 2 and maybe from 4 here also, right? So with the help of negative remainder, we are able to just ease our calculation a bit. So what we will get here is -1 into -1, that is +1, into 2, that is +2. But because we have cancelled out 5 from numerator as well as denominator, so we will have to multiply this result with 5 to get our final result. So this will come out to be 10. Also, one more thing, one more important thing is that even though we can write the negative remainder, but we never leave the final answer in terms of negative remainder. Okay, even though that's why I told you one reason there. For example, let's say I divided 19 by 7, then the remainder was 5 or -2. Okay, so I told you that the sum of the magnitudes will be equal to 7, right? So even though if I know that, okay, I have got the final answer as -2, but because we never write the final answer as a negative remainder, so we can just subtract 2 from 7 to get the positive remainder, that is 5. So that's why I told you that the sum of these numbers will be equal to this. So if the final answer comes out to be negative, so we can just subtract that from the denominator and get the positive remainder. Okay, I think this should be clear. Okay, one more thing, I think, for the next point. Also, remainder cannot be greater than the denominator. Looking at the same example, let's say instead of the negative remainder, I take the positive remainder. That is uh, because it is 189, so 185 will be divisible by 5, right? So 4 will be the positive remainder. So this will be 4 multiplied by, it is already a positive remainder, that is 2. And here the positive remainder will be again +4. So what we are getting here is that 4 into 4 is 16, into 2, 32. So because we have divided these numbers by 5, so the remainder cannot be greater than 5, right? So when you are dividing any number, let's say if you are dividing 19 by maybe let's say 8, so 8 into 2 is 16, so remainder will be 3. Okay, if let's say I take a larger number here, maybe 23, so the remainder can be 7, because 8 into 2 is 16, so remainder will be 7. If I take here 24, so it will be 8 into 3, that is 24, and the remainder will be 0, right? It will be completely divisible. So you can see that the remainder cannot be greater than 7 if I am dividing the value with 8. So same way here, because I am dividing the values by 5, so the remainder cannot be greater than 5. Okay, so what we can do, if we are getting some values that are greater than the denominator, then we can further divide it by 5 or whatever the denominator is. Okay, so we can divide it by 5. So 5 into 6 is 30, so remainder will be 2. So we have got the remainder as 2, but again because we have cancelled out 5, so we need to multiply this number by 5. So that will be 2 into 5, essentially 10. So we have got the positive remainder. By using the logic of negative remainder also we can get to the answer. By using the logic of positive remainder also we can get to the answer. So the last part was telling us that remainder cannot be greater than the denominator. So I just try to explain you that when we are getting any value which is greater than the denominator, we can just divide it further with the same value till the time we are getting a value that is smaller than the denominator. Okay, and also don't forget to multiply the final answer with whatever value you have cancelled out. Okay, I think this should pretty much clear. This was about this particular concept. I think this should be clear. If you have any doubt, you can just put it in the chat box. Okay, Dipesh, you're not able to view your application form. So have you tried logging in on the official website? If you still face any issue, I think you can just mail the official website, or go to the official website of IIM Bangalore and you can mail them. I think they will definitely get back to you. If there is some glitch from their end, they will get back to you. And either one more thing that you can try is just try to clear out the cache of your browser and try to relog in maybe from some other device also if the issue is from your end. Okay. No, the session is starting at 8 p.m. It is not only till 8 p.m. So okay, sorry. So the application time is over. You are replying to Dipesh. Sorry. Okay. I think this slide is clear so that we can move to the next slide. Yeah. So like I told you, after remainders, we will be looking at unit digit. So what does unit digit mean? Let me change the pen. Okay. So if I'm writing any number, let's say, if I'm writing a number, let's say 2, okay, this is some other. Let's take the earlier one itself. But this has just changed the color. Okay, white. Yeah, white will work. Okay, right. Yeah, so I was talking about unit digit. So if I'm writing any number, let's say 2437 or any number, so the last digit is called as unit digit of that particular number. Okay, for any number that I'm writing, be it let's say 44791. So the last digit is called as unit digit. Okay. So how do we calculate the unit digit for any number who is raised to some high power? Maybe let's say if I can take one example. Let's say for the same number I have 2457 raised to the power 2319 or something like that. So it is not feasible to multiply this number this many times, right? So there should be some method using which you will be able to solve this kind of questions. So basically what we need to do is we need to find the last digit, that is unit digit of this number, when we will open this, let's say, bracket, and we will multiply 2457 this many times. So the number that will come to the last digit, rightmost side, that is the unit digit, we need to find that. Okay. So if the unit digit is 0, 1 or 5 or 6, for example, okay, for example, let's say I have any number 2450 multiplied by, oh sorry, not multiplied by, raised to power 491, let's say. So I need to multiply this 491 times, and I need to find what will be the unit digit. So because this number is ending in 0, so it doesn't matter how many times I multiply this number, the last digit that is unit digit will always be 0, right? So if you are multiplying it, let's say 2450 multiplied by 2450 and so on, so it doesn't matter how many times you are multiplying this number, the unit digit will always remain as 0, right? So it doesn't matter what power it is, if any number is ending in 0, and same is the case for 0, 1, 5 and 6. It doesn't matter how many times you are multiplying that number, the unit digit will always remain the same. Okay, if for the same number, let's say it was 2451, so it doesn't matter the whatever value of power you put here, the unit digit will always remain the same, that is 1, because 1 multiplied by 1 multiplied any times, it will result in 1 itself. Same is the case for 5 also. So let's say I'm taking the same example, that if it is, let's say, 2455, so it doesn't matter how many times you multiply this, it will result in 5 only. Same for the case of 6 also. Okay, so if you are asked to calculate the unit digit of any number, that is, let's say, 4976 raised to some very large power, so just by looking at the unit digit, that is 6, you can tell that the last digit of this product, or let's say when you will be opening this and multiplying all the power, then the last digit, that is unit digit, will be 6 only. So for 0, 1, 5 and 6, we can directly remember that the unit digit will be same as the unit digit of the number. Okay, because 6 multiplied by 6 is 36, 36 multiplied by 6 is 216, and so on. So it will result in 6 itself. Okay, so this was case 1 about unit digit. Let's look at case 2. So we have done with, because we know that the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we are done with 0, 1, 5 and 6. So 0, 1, 5 and 6. Now let's look at 4. Okay. So when any number that is ending in 4, let's say I take a single digit number as 4. So if it is raised to some power and we need to calculate what will be the unit digit. So with the help of this, that if the power is odd, then it will always end in 4 as the unit digit. And if the power is even, then it will always end in the unit digit as 6. For example, let's say I have a number 4 and it is raised to power 231, right? So because this number is odd, so when we will be solving it, then whatever number will come, the unit digit will always be 4. Whatever number will come, but the unit digit will always be 4. And if I had taken, let's say, the same value, but the power is even, maybe let's say 250. So this is the even power. So whatever the result will come, but the unit digit will be 6. So just by looking at the power of any number that is ending in 4, so just by looking at the power, we can tell what will be the unit digit. Okay, so same you can do for numbers which are just not a single digit numbers. For example, let's say if I have any number 2, 3, 1 or 4. So I have this number and this is raised to some power. So by just looking at this number also, if the power is even, so the unit digit will be 6. If the power is odd, then it will be 4. Okay, I think you can remember this also. And same is the case for 9 also. If the power is odd for that number, for the same example you can take, let's say the value is 9 and it is raised to power 231. So because the power is odd, so the whatever the result will come, the unit digit will be 9 only. Okay, and if the power is even, let's say 250 again I'll take. So whatever the value will come, but the unit digit will always be 1. Okay, I think this should be pretty much clear. So for 4 and 9 we can directly remember this. And also one more thing is that you need not to remember this. Actually what you can do is, because 4 raised to the power 1 will end in 4, so 1 is odd value, right? So for if you have any odd power, so you can just check it with 1. If there is a power of even, so you can check it with power of 2, right? So if it were, let's say, 4 square, that is even power, so this will be 16, right? So the unit digit will be 6. Same is the case for 9 also. If the number, let's say if number is 9 raised to power 1, so unit digit will always be 9, because 9 raised to power 1 is 9. And if it is a 9 square, that is 81, so the unit digit will be always be 1. So instead of remembering, if you feel that okay, I'm not able to recall all those things, so you can check it with the very basic value. For example, if it is an odd number, you can check it with power 1. If it is an even number, you can check it with power 2, so that you are not forgetting these things. Okay, so this was case 2 about unit digits. So now our 4 and 9 is also done. Now for 2, 3, 7 and 8, it follows cyclicity. Then what is cyclicity, sir? Let's see what is cyclicity now. Okay. Let me write a few powers of 2. That is 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, 7, 8, 9 and 10. Just to explain you the concept, I think it will be clear with these many values. Okay, so 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, 2 raised to the power 3 is 8, then it is 16, then 2 raised to the power 5 is 32, then it is 64, 2 raised to the power 7 is 128. I think you should know these values. These are pretty basic values. 256, 512 and 1024. Okay, so why I have written these values? See, after the initial 4 values, you can see that the unit digit is getting repeated. So 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, 2 raised to the power 3 is 8, 2 raised to the power 4 is 16. So the unit digits are 2, 4, 8 and 6. Just look at the unit digit. That are 2, 4, 6 and 8. And you can see the same pattern is getting repeated, right? So the unit digit of 2 raised to the power 5 is same as 2 raised to the power 1, that is 2. And for the 2 raised to the power 6, the unit digit is same as 2 raised to the power 2, that is 4, and so on. The 8 will also repeat, 6 will also repeat, and you can see that now again the same pattern is getting repeated. Okay, so 2, 4, and then 8 and 6 will get repeated, and so on. Okay, so what we can tell from here is that the meaning of cyclicity is that after a certain point in time, the values are getting repeated. So if I am asked to, let's say if I ask you to calculate the unit digit, right? If I ask you to calculate the unit digit of, let's say 2 raised to the power 17, right? So what you can say that, okay, because the values are getting repeated after 4, so the unit digit of 2 raised to the power 17 will be same as 2 raised to the power 13, then 2 raised to the power 9, then 2 raised to the power 5, and 2 raised to the power 1. So 2 raised to the power 1 is 2, so you can say that the unit digit will be 2. But again, doing it manually will be, it is possible for some smaller values, but to manually calculate for some larger values, I guess it will be pretty much difficult. Okay, so you just can't say that, okay, from 17 we are coming to 13, then 9, then 5 and 1 and so on. Okay, so what you can do is that you can just, because you know that after every 4 values the unit digit is getting repeated, so what you can do is 2 raised to the power 17 it is, you can just divide it by 4, you can divide the power by 4 and write the remainder. So here in this case the remainder is 1. So this remainder means that you need to check 2 raised to the power 1, that is 2. Okay, let me take one more example. Let's say I have 2 raised to the power 34. Okay, this is a different example. So what I need to do is I need to just divide the power by 4, and I need to just write the remainder. So I will divide it by 4. What I'll get is, because 4 into 8 is 32, so remainder will be 2. So remainder is 2. So what I need to do is I just need to calculate 2 raised to the power 2, that is 4. So the unit digit of 2 raised to the power 34 will also be 4. I think this should be clear by 2 examples. So same is the case for other values also, right? So this cyclicity is being followed for 2, 3, 7 and 8. That means that after every 4 values, all the remaining values will follow a pattern. The first 4 will be same, the next 4 will be same, the next 4 will be same, and so on. Okay, so I think you can remember for 2, 3, 7, 8 that they follow a cyclicity. All you need to know is that the first 4 values. So for example, for 3, you just need to know the initial 4 values. 3 raised to power 3, 3 raised to power 4. So the unit digit here will be 3, here it will be 9, here it will be 27, it will be no, 243, yes. No, it will be 81. Yes. So this pattern will continue. So 3 raised to the power 5 will be 243, then it will be 729 and so on. Okay. So this value will continue. So you need to focus on initial 4 values. So 3971, 3971, and this will continue. Okay, so this I think you can remember the first 4 values of 2, 3, 7 and 8, and all the further values you can calculate. If it is a very large value, you can divide the power by 4 and you can check the new remainder. If the remainder is 1, you need to check just the power raised to power 1, the number raised to power 1. If the remainder is 2, you need to just check the number raised to power 2 and so on. One more doubt that you can ask here is that what if the remainder is 0, right? Let me take one example. Let's say I have a value 2 raised to power 72. If I am dividing it by 4, because 72 will be completely divisible by 4, so I will be getting a remainder as 0. So if I am getting a remainder as 0, so in that case I need to check the fourth power. That is 2 raised to power 4 is 16. 6 will be the remainder. So apart from that, if the remainder is 1, you can calculate the power as 1, 2 raised to power 1. If it is 2, you can calculate 2 raised to power 3. So only when the power is completely divisible, that is if the power is a factor of 4, so what you can do is because the remainder will be 4, you need to just check the fourth power of the number. I think this should be also pretty much clear, because this is a common doubt that can happen. Okay, you need to just check the fourth power. So you can apply this for 2, 3, 7 as well as 8. You just need to know the initial 4 powers to calculate the unit digit. I hope this should be clear. If you have any doubts, you can just ask. Okay, I don't think you have any doubts. Okay, because you don't have any doubt, we can continue. So yes, all the numbers are done. 2, 3, 7 and 8 are also done. So this was about unit digit. Moving ahead, now we need to find the last two digits. If a number is in the last case, let's say we have a number 2501 or something like that. So this was the unit digit. Now we need to find the last two digits. So not just the unit digit, we need to find one more digit that is on the tens place. So we need to find the last two digits. So how we are going to find it? Let's see. Here are also a few cases. Starting with case number 1. If the unit digit of the number is 1, then multiply the tens place of the number with unit place of the power. The unit digit of the resultant number will be tens place of the actual number. I think this must have been gone a bouncer kind of, because काफी कुछ यहाँ पे लिखा हुआ है. Let's try to take an example and help you with it. Okay. So one condition is that if the unit digit of the number is 1. Okay. Let's say I have a number 21 raised to the power 539. Let's say I take an example that is 21 is raised to power 539. So because this number is ending in 1, so we know that the unit digit will always be 1. So the unit digit is 1. But for the tens digit, what we need to do is multiply the tens place of the number by unit place of the power, and whatever the result be, write the unit place of the power in the tens place of the number. Okay. So if the example is 21 raised to the power 539, so the unit digit is 1 of the, we need to find the last two digits. So of the last two digits, the unit digit is 1. Okay. And to find this number, we are multiplying the tens digit of the number with the unit digit of the power. So 2 into 9 is 18, right? So now we need to write the unit digit of this number as the tens digit of the resultant, whatever the final result is we are going to derive from it. Okay, so here the unit digit is 8, so it will be 81. So this is the result, and this was the case 1 that multiply the tens place of the number, and so on. It was written. Okay, I think I should take one more example so that it is more clear to you. Let's say I take a number as 2531 multiplied by 5923. Let's say I have taken this number. Okay, so what I need to do is, of course, we know the unit digit is of course 1. For the tens digit, we need to multiply the tens digit of this number with the unit digit of this number, that is 3 into 3 will give me 9, and of course because it is a single digit number, so we can write it 9 and this one as it is. So let's say in this case it was 2 4. Just to give you more clarity, so because this is 3, this is 4, so we will multiply 3 with 4, it will give us 12, right? So it will give us 12. So we need to just write the unit digit of this number as the tens digit of the number, that the tens digit of the final answer, and we know that it will end in 1, so the unit digit is always 1. So this is the answer. So I think this should be clear now. To calculate the last two digits of any number that is ending in 1, what we need to do is just first of course write the unit digit as 1, and then multiply the tens place of this number with the unit place of this number, and whatever the final answer is, you can just write the unit digit of this number as the tens place of this number, and of course it will end in 1. So I think this should be now clear. The case 1 should be now clear. If you have any doubt, you can ask me. I'll just explain the case 2 also, and if you have any doubt, I'll take it after case 2. Okay. So for case 2, we can convert any power of 3, 7 or 9 to unit digit as 1 and can refer to case 1. Okay, 3, 7 and 9. So because we know that 3 raised to the power 4 is 81, 7 raised to the power 4 is 2401, and 9 raised to the power 2 is 81 also. Okay, so if we are asked to calculate the last two digits of any number which is ending in 3, 7 or 9. Let's start with 3. Let's say I have a number 3 raised to the power 592 something, this, or maybe I can take 590. Okay, so I need to calculate the last two digits of this number. So because I know that I can convert 3 to any number that is ending in 1, and if I get a number that is ending in 1, then I can use my first case, right? I can use my first case. So what I need to do here is I need to just convert it into 3 raised to the power 4. So 3 raised to the power 4, I will get some value here multiplied by the remaining value, right? So I just need to convert this into this particular form. So how I can do it? What you need to do is divide 590 by 4. Divide 590 by 4. Write the quotient here and the remainder here. That is 4 into 1 4, 4 into 4 16. 3 is so 4 into 7. I hope my calculation is okay. 4 into 1 4, 4 into 4 16, 3 is the remainder 30. So 4 into 7 28. So because 2 will be the remainder, because 30 was remaining, so I multiplied 4 by 7, that is 28. So 30 minus 28 is 2. So I need to just write the quotient here and the remainder here. Okay, so the quotient will come out here and the remainder will come out here. So if the number is perfectly divisible by 4, so you won't be getting any value here. But if there is some remainder, if the number is not completely divisible by 4, so you will be getting some value and you can write that value here. So now because we are able to write it in the form of 3 raised to the power 4, so we have converted it into some number that is ending in 1. So we know that 3 raised to the power 4 is 81. So 81 raised to the power 147 multiplied by 3 square. 3 square is 9, right? So now we have converted 3 raised to the power 590 into a number that is satisfying our first case. So what we can do, of course the unit digit will be 1. So what you need to do is multiply the 10th digit of this number with the unit digit of the power. So 8 into 7 is 56, and of the 56 we just need to write the unit digit. So out of 56 we will write 6. So it will be 6 into 9. So this 9 into 1 is 9 and 6 into 9 is 54. So the last two digits of this number will be 4 and 9, that is 49 of course. Okay, so I think this should be clear that if we are getting any number that is ending in 3 or 7 or 4 or so now we can convert these values to a number that is ending in 1, and we can use the case 1. I think you can I can explain one example using the second value also, that is 7, so that it is pretty much clear to you. Okay, there should be no doubts. Okay, so if I have a number, let's say 7 raised to the power, if I take any number, maybe 278. Okay, I'm taking 278 because it is not divisible by 4. 280 will be divisible, right? Yeah. So now I need to check 7 raised to the power 4, that is 2401. So 7 raised to the power 4, some value will come here and some value, that is the remainder, will come here. So because I'm taking a number that is not divisible by 4, so some remainder will come, right? So what you need to do is divide just 278 by 4. So 4 into 6 is 24, 3 is the remainder. So 38, 4 into 9 is 36, right? Yes. So 69 here and 2 will be the remainder. Okay. So we have to write just the quotient here and the remainder here. So now we know that 2401, 7 raised to the power 4 is 2401 raised to the power 69 multiplied by 7 raised to power 2 is 49. I hope I'm doing the right calculations. There's no calculation mistake here. 7 into 4, 28. Yes. Yeah. So now, of course, the unit digit is 1. Now, we need to multiply this 0 by 9. So this will, of course, be 0. So we need to multiply this by 49. So, of course, this will come out as 49. Okay. Just because the unit digit here was 0. So I thought if I take example, so it will be more clear to you. So let's say if the final answer comes out to be in a single digit, let's say by doing all these calculations, the final answer comes out to be maybe 5. So what you need to do then is just add a 0 here. Okay, just in considering a case when the final answer comes out to be a single digit number and you have done the concept, you have done the calculations correctly. So what you need to do is just add a 0 here to get the last 2 digits. I hope that is clear. For 7 also, I think you can do it for 9 also. Using the same things, you can do it for 9 also and this will satisfy. Things should work out for you. Okay, let me see if you have any doubts. Otherwise, I'll move to case 3. Okay, there are no doubts. Right. Let's move to the next case. That is case 3. Case 3. So, for 2, 4, 6 and 8, you need to remember that 24 raised to power odd number is 24 and 24 raised to power even number is 76 and 76 raised to power any is 76. Okay. So what essentially we are doing here is that we need to remember that 2 raised to power 10 is 1024 and now this 24 raised to any power will result in 24 as the last 2 digits. So if we have any larger number, let's say I need to calculate the last 2 digits of a number 2 raised to power 592. Okay, we need to find the last 2 digits of this number. So we know that 2 raised to the power 10, it will be 59. I think I have already explained you that 59 into 10 is 590. So 2 will be the remainder. So you can write 2 square here. Okay. So now we know that this is 1024 of course, but we need to just focus on the last 2 digits. This is raised to power 59 and 2 raised to power 2. See again, one more thing. Like here also, like I have written that you need to remember that 24 raised to power odd is 24 and 24 raised to power even is 76. So you can just check it for smaller values, right? So if it is a 1024, the number is, if it is raised to power 1, then the last 2 digits will be always be 1. So if I need to check for the odd number, so I'll start with 1 of course. And if I need to check for the larger number, let's say 24 is a square, that is an even number, smallest even number is 2. So the last 2 digits will be, because the square of 24 is 576, so you can check it here and like this also. It is not that you need to memorize all those things. You can check it by taking a few values, and of course you will be starting with some smallest value so that you are not left with calculating larger values. So I think you can remember that, or you can do them in calculation also. So because this is an odd number, so 1024 raised to power odd number will be 24 only. So this will be 24 multiplied by 4. This will come out to be 96. So the last 2 digits, of this number, this number, that is 2 raised to power 592. So the last 2 digits will be 96. Okay, so for this you just need to convert it into 2 raised to power 10 and write the remaining values here. You can just multiply it. I think by now this should be pretty much clear. Okay. If it is clear for 2, I think this should be clear for 4 and 8 also. I'll come to 6, but just look at 4 as well as 8. Okay, so if the number is, let's say I need to calculate the power 4 raised to power, maybe let's say 291, I guess. Okay, 4 raised to power 291, I'm taking some random values. I think this should be visible, right? I write a bit larger. Okay, so 4 raised to power 291. So what I can do is I can convert it into 2 raised to power some. So I can write it as 2 square 491. So it is 2 into 1 is 2, 9 into 2 is 8, 1 carry, 4 into 2 is 8, 1 9. So I have now converted this value. Okay, this was 291, but I made some silly mistakes. Yeah, so this was 291. So 2 into 1 is 2, 9 into 2 is 18, 1 carry. So 2 into 1, 5, yes. So I have now converted 4 raised to the power 291 into 2 raised to the power 582, and now I can use the concept that I used for 2, that is 2 raised to the power 10. Of course, it will be 58 times, and now it is being multiplied by 2 raised to the power 2. So 58 into 10 is 580, and 2 is the remainder, so I can write it as separately. Okay, so because this is an even number, so the last two digit will be 76 multiplied by 4. So 6 into 4 is 24. So 2 carry, 7 into 4 is 28, and 3. So the last two digits will be 04. Okay, so if apart from 2, I can do it for 4 also, and I can do it for 8 also. If it was a case for 8, so if it was a case for 8, let's say it is raised to power 140 maybe, just to explain it. So what I can do is I can write it as 2 cube raised to the power 140. So it will come out to be 2 raised to the power 420. And after that, I think it is pretty much clear. You can just convert it into 2 raised to the power 10. That is 2 raised to the power 10 raised to the power 42, because there is no remainder left. So because the power is even, the answer will come out to be 76. So this should be clear for 2 as well as 4 as well as 8. And for 6, you need to just remember one thing, that 6 raised to the power 5 is 7776. That is 6 raised to the power 5 will give me 666. Sorry, 7776. Okay. So, and also one more important point is that here it is written that 76 raised to any power will give me 76. Okay. So if I am to calculate the last two digits of some number, maybe 6 raised to the power, let's take a small example, easy number now. Let's say it is raised to power 100. So I need to just convert it into 6 raised to the power 5, like I am doing for the last, for this slide for 2, 4, 8. I'm doing this the same thing. So this will completely divide, right? 100 divided by 5 will be 20. So because this number has the last two digits as 76, so 76 raised to any power will give me 76. So I can, because this number is completely divisible, I can just write the last two digits as 76. In case, let's say I had a value that is 6 raised to power, let's say 102. So now what I need to do is 6 raised to power 5 raised to power 20, because 20 into 5 is 100, multiplied by 6 raised to the power 2. So from here I know 76 raised to any power will give me 76. So 76 multiplied by 36, I just need to multiply these two values and I'll get the final answer. I think that should not be the purpose. You can just do the manual calculation, but the process should be clear, right? That is more important. So you can just multiply 76 and by 36 and you will get the final answer. So for 6 also, you can just need to remember that 6 raised to the power 5 is 7776, and using that you will be able to calculate the last two digits. I hope this should also be clear. Only one case is left now, that is case 4. It is for 5. Only 5 is left, right? So the tens place of base and unit place of the power are both odd, then the last two digits will be 75, else 25. Let's say I take a number 2, 4, 3, 5, 3, 1, 2, 6. Okay. So the tens place of base, that is this, multiplied by, sorry, and the unit place of power, that is this. Okay. So if both are odd, then the last two digits will be 75, otherwise 25. So now because one is 3 and one is 6, so both are not odd. So the answer will be 25. Okay, so there is only one condition in which I can get the last two digits as 75. Let's try to explain this. Okay, so 2435 raised to the power, let's say 24, not 24, let's say 1516 maybe. So we just need to check the tens place of this number with the unit place of the power, and if both are odd, then the unit digit, then the last two digits of the number will be 75, otherwise it will be 25. So in this case it will be 25. If let's say this number was even, maybe 2 4 6 5 raised to the power 1 3 2 maybe 1. So if this number is also even, any number is even, then the answer will be 25 only. The last two digits will be 25. The only case in which the answer will be 75 is when both this as well as this are odd numbers. So if both are even, then also 25. If either one of is even, if this is even, then also 25. If this is even, then also 25. The only case if when the both of them, that this as well as this, both are odd, then the resultant will be 75. Resultant means the last two digits. Okay. So the tens place of base and the unit place of power, if both are odd, then the last two digits will be 75. Otherwise, for all the three cases, it will be 25. So this was a case was 5. I think this should be clear. If you want to ask any doubts, you can just put it in the chat box. Okay, I can't find any doubts. So I can move to the base system. So generally when we write any numbers, so we use the decimal system. In the decimal system, the base is 10. That is because when we represent any value, that let's say if I'm writing 75, then this is in base 10, because in base 10 we have digits from 0 to 9. So we have this is from 0 to 9, this is base 10, right? So if I want to just, let's say, convert this base to any other base, so we will learning that in this particular slide. So how to convert any value from base 10 to any other base, or maybe from any other base to base 10. Okay, so let's say if we want to convert base 10 to any other base, so we can just successively divide that number in base 10 and then write in reverse. Okay, so let's say I want to convert any number. Let's say, again I'm taking example, let's say I have a number 75 that is in base 10, and I want to convert this number from base 10 to a number in any other base. Let's say I want to convert it in base 8. So what does that mean? That if a number is in base 8, so the digits that I can use will be from 0 to 7. In this base 10, the digits that we use are from 0 to 9. So here the digits will be from 0 to 7. If the base is, let's say, 6, so we can use the digits from 0 to 5. Okay, so we can't write 8 here because that is the base. So the maximum digit that we can write here is 7. So how we will be converting it? So we can just successively divide this. So this is the process to convert it. So 8 into 9 is 72. So 3 will be the remainder. 8 into 1 will be 8. So 1 will be the remainder. And 8 into 0 is 0. So 1 will be the remainder. So 1, 1, 3. So by reverse, it means we need to start from here. So here we will be writing in 1, 1 and 3. So we have essentially converted 75 from base 10 to a number that is in base 8. Let's take one more example. Let's say I want to convert any number, say 92, that is in base 10, and now I want to convert this number to any other, let's say in base 6. So I want to convert this number from base 10 to a number in base 6. So like I told you, we can just do the division and write the numbers in reverse order, the remainders in the reverse order. So here we will be writing as 92 divided by 6. So 15 into 6 is 90. So 2 will be the remainder. 6 into 2 is 15. Sorry, 6 into 2 is 12. So 3 will be the remainder. 6 into 0 is 6. So, sorry, 6 into 0 is 0. So 2 will be the remainder. Okay. So we need to just write these numbers. So 2, 3, 2 in the reverse order. So first 2, then 3, then 2. Okay. So essentially we are converting this number from base 10 to a number in base 6. So here the base is 6. So I think I can take one more example to help you understand what is the purpose of this. So if we do some manual calculation, for example, in the school time, when we just, let's say, take a very basic example, if I want to subtract 9 from 21, so how we used to do, because 1 is smaller than 9, so we can't just directly subtract. We cut here 2, we cut 2 and write it here 1, and also here we write it as 11. So what we have essentially done here is that we have taken 10 carry from here, because the base was 10, so we have added 10 to the right hand side. So here from 1 it is 11 because 10 is added because the base was 10. So if in this case, let's say the base is 8, so when we will be to do the calculation, if we will cut this number and take some carry, then it will be equivalent to the base. If the base is 8, then we will add 8 to it. If the base is 6 or 7, then we will add 6 or 7, because we do all the calculation in base 10. So essentially we just add 10 to the to this number and you do the manual calculation. That is of course 2 and 1. Okay, so I think this should be clear using this example about what is base, and now you should be able to convert any number that is in base 10 to any other to a value that is in other in the base that is asked. For example, let's say if you want to convert from base 10 to any other base, so I think you will be able to convert it. Now let's look at if you want to convert from any base to base 10. For example, let's say you have a number 2, 5, 1 that is in base 6. Now you want to convert it into base 10. So what you need to do is just look at the base value, that is 1. So 1 into 6 raised to the power 0, right? 5 into 6 raised to the power 1, 2 into 6 raised to the power 2, and so on, right? So 1 into 6 raised to the power 0, 5 into 6 raised to the power 1, 2 into 6 raised to the power 2, and so on. If there was one more number, let's say I write 1 here, so 1 into 6 raised to the power 3. So what I will get here is 2 into 36, 6 square is 36, plus 5 into 6 plus 1 into 1, because any number raised to power 0 is 1. So this will come out to be 72 plus 30 plus 1. So that is 102 plus 1, 103. So we have essentially written 251 from base 6 to 103 in base 10. I think this should also be clear. Let me take one more example. If I want to convert any number, let's say 2, not 2, okay, 5, 3, 7. This is written in base 8, and now I want to convert it into base 10. So what you need to do is just multiply this 7 by 8 raised to the power 0 plus 3 into 8 raised to the power 1 and 5 multiplied by 8 raised to the power 2. That is 5 into 64, just doing the manual calculation now. 3 into 8 plus 7 into, of course this is 1, any number raised to power 0 is 1. So 64 into 5 will be 320. 18 into 3 is 24. Then yes, this should be 7. You can just add it. This is 344 and 7, 351. I hope I'm doing the calculations correctly. So this will be 351. Okay, so now you will be able to convert any number from base 10 to any other base and number from any other base to base 10. So these things I have written it here also. Okay, yeah. So just multiply unit digit with base raised to power 0, tens place with base raised to power 2, and so on. That is unit digit with base raised to the power 0, tens place with base raised to the power 1, 100 place with base raised to the power 2, and so on, so that we are able to convert this number from base 8 to base 10. I think this should also be clear. So this was about base system. There's one more thing. If we are representing any larger base more than 10, so we can represent 10 as A, 11 as B, 12 as C, 13 as D, and so on. So let's take an example to understand this also. Let's say you have a value, let's take a larger number now, 5, 4, 2, 1, 6. 5, 4, 2, 1, 6. And you want to convert this number from base 10 to maybe base, okay, let's take it as base 16. No, I think this should be pretty much okay. Let's take as base 14. So if this is 5, 4, not this way, it should be this. Yeah. So 5, 4, 2, 1, 6. We need to convert it into base 14. So we need to just write 14 here. So 14 into 3 is 42. 42, so 12 will be the remainder. So 122. So 14 into 8. 14 into 8 will give me 112. So 10 will be the remainder. So 101. So for 101 it will be 14 into 7, I think 98. So 3. So 36. For 36 it will be 14 into 2, 28. So 8 will be the remainder. I hope I have done the right calculation. Let me cross verify once. Let me see if I have done the correct calculations. So 3872 multiplied by 14. Yes, it's correct. Okay. Just to avoid any calculation mistake, so this will be 8. Now 14 into 2 is 28. Okay, right here. 14 into 2 is 28. So 10 will be the remainder. So 10 or 7, 107. So 14 into 7. So 14 into 7 is 98. So 9. So 92. So for 92 it will be 6. So 92 it will be 6. So 14 into 6 is 84. 84. So 8 will be the remainder, right? Again, I think I have made some error. Okay. So 276 into 14. Yes, it is correct again. Yeah. So now it is 14 into 1, that is 14. So 136. So 136 it will be 9. 14 into 9 is 128. So I guess again and again 8 is coming. So 14 into 19, 14 into 1 is 14. So 30 is the remainder. So 136. So 14 into 9 is 120. So 126. So 10 will be the remainder, right? So 14 into 9 is 126. So 10 will be the remainder. So now it is 14 into 1. That is 14. So 5 will be the remainder. And 14 into 0. So 1 is the remainder, right? So basically I was looking at a value that is digit that is greater than 9. So now you need to represent this. So how you will write it as 1, 5. This is as 10. Then double 8. Right? Because this is a single digit, we can't write 10 here. So we can represent 10 as A, 11 as B, 12 as C, 13 as D, and so on. So 14 as E, and so on. Okay. So what we can do here is we can represent 10 as A. So essentially this is the, so for this value in base 10, this will be the representation in base 14. I hope this should be clear, because we are representing this as as alphabets, that is A, B, or C. So because of that, I think I should have taken an example so that it is clear to you. So the answer will be 1, 5, A, 8, and 8. So here A is representing 10. And because in base 14 there are 13 digits, there are 14 digits from 0 to 13. So in this base we can represent 10 as a single digit. So representing 10 as a is a single digit, right? So likewise, you can do for any base, be it 11, 12 or 13. You can just follow the same approach, and whatever the remainder is, you can represent it as per this notation, the 10 as A, 11 as B, and so on. I think now this should be clear. This was about base system. If you have any doubt, you can just ask me now in the chat box. Okay, I don't think there are any doubts, so we can move ahead. Okay. Okay, let's solve a few questions now. You need to find the remainder when 15 raised to power 963 is divided by 720. You can try this question now. 90 seconds. I think this should be enough for this question. Try this. Okay, the time is up. Let's try to solve this question. So we we are asked to calculate the remainder when 15 raised to the power. Okay, let's write it here. 15 raised to the power 963 is divided by 720. Okay, like I told you, if we have something in common in the numerator and denominator, we can just cancel that out. So we know. So just breaking 15 raised to the power 960 as 15 raised to the power 961 multiplied by 15 multiplied by 15, that is power 1 and 1, so it is 15 raised to the power 963. I have represented it as 15 raised to the power 961, and I've taken two 15s separately so that I can cancel it out from the denominator. Okay, so this is divided by 720. So 15 into 4 is 660, 12, so 12, 120. So 15 into 8 is 120. Okay, I think I can cancel 3 more. 3 into 5 here. So 3 into 16. Nothing will cancel out. So 15 and 3. So I have cancelled out 15 and 3. So I will have to multiply this also. Right? I have cancelled out 15 and 3. So I will have to multiply this also. So now what I am left is 15 raised to the power 961 multiplied by 5 divided by 16. So now the concept of negative remainder will help you, because 15 divided by 16 will give me remainder as either 15 or minus 1. So because I need to just ease my calculation, what I can do is I can write the remainder as minus 1. So minus 1 raised to the power 961 multiplied by 5. Okay. So because 5 divided by 16 will giving me 5 only remainder. So minus 1 raised to power, see 1 raised to power, any power you can raise to 1, it will give me 1 itself. So because it is minus 1 and it is odd power, so the resultant will be minus 1. So if it was an, let's say instead of minus 1 it was plus 1, so any power you can raise to 1, it will give me 1 only. but because it is -1, so we need to check the power also. Because it is -1, so the resultant will be negative, that is -1. So what we will get here is -1 into 5, that is -5. So because I told you, even though we use negative remainder to ease our calculation, but we don't write negative remainder as the final answer. So what I can do is just subtract this 5 from 16 to get our positive remainder. That will be 16 minus 5, that is 11. And also because I have cancelled this out from the numerator as well as denominator, I need to multiply this also. So this will come out to be the final answer, that is 11 into 15 into 3, that is 11 into, this is 45. So this will be 450 plus 45, that is 495. This will be our final remainder. Okay, option number A. I hope this should be clear. If you have any doubts, you can just ask in the chat box. If you don't have any doubts, we can move ahead to this question. You need to find the last two digits of this term, that is 2 raised to power 50 minus 2 raised to power 20. Try this question. You have 90 seconds for this. Okay, so the time is up. Let's try to attempt this question. So we need to find the last two digits of 2 raised to power 50 minus 2 raised to power 20. Let's do it term wise. So what will be the last two digits of 2 raised to power 50? So what we need to do is, because it is 2 raised to power 50, we know that 2 raised to the power 10 is 1024, right? And also because if we are multiplying 24 for odd number of times, the last two digits will be 24. If we are multiplying with even for even number of times, then the last two digits will be 76, like we discussed in the earlier slides. So here the power is 50, that is 2 raised to power 10 raised to power 5 for 50. So this will be odd power. So by odd power it means the last two digits will be 24 only. Okay, this is 24. So for 2 raised to power 20, let's do for 2 raised to power 20 also. So for 2 raised to power 20, it is 2 raised to power 10 square, that is 1024 square. So because it is an even power, so the last two digits will be 76. What we need to do is, now we need to find the last two digits. We need to subtract this from this. So it is essentially 24 minus 76. So because this is a smaller value, so sorry, because this is a smaller value, this can't be negative. So we can just take one carry from the hundreds place. Okay, there will be some values here also, na. We can take one carry here. So this will come out to be 124 minus 76. We are taking some carry because this will of course be some larger value. It is 2 raised to power 50. It will be a larger value. So we can just take one common from the right hand side, the 100th place term, and subtract it. So this will come out to be 124 minus 76, that is 48. So the last two digits of this subtraction will be 48. Okay, I should write here so that it should be visible. Okay, I think this was an doable question, not too difficult. And the solution should also be clear. If you have any doubts, you can just ask in the chat box. Otherwise, we will move to the third question. Let's see if you have any doubt. Okay, if you don't have any doubt, we can just move to this question. Okay, this is from base system. Try to solve it. You have 2 minutes time. Try to attempt this question. Okay, the time is about to end. Let's try to see this question. So we don't know the value of x, right? In which base these values are written. Okay. So we need to find 41 in some base x multiplied by product. No? Yes, the product 12 in the same base x is given us 1042 in the base x, right? So we know that to convert it into base 10, what we do is this 1 multiplied by x raised to power 0 plus this 4 multiplied by x raised to power 1, right? To convert it into base 10. Same for the other value also. What we can write for the second value also, I guess it is visible, right? So 2 multiplied by x raised to power 0 plus 1 multiplied by x raised to power 1. 1 multiplied by x raised to power 1. Same way for the right hand side also. I think I should write here so that it is clearly visible. I'm writing the right hand side here. So it is 0, 1, 2 and 3. So 1 multiplied by x raised to power 3 plus 0 multiplied by x raised to power 2 plus 4 multiplied by x raised to power 3. Sorry, okay, this is should be x raised to power 1 plus 2 multiplied by x raised to power 0. So we have essentially converted this into base 10. Now just solving it. Okay, so the x raised to power 1 is x. So this is 4x plus 1 because x raised to power 0 is 1, multiplied by this is x plus 2. Solving the right hand side also. So this is x cube basically plus this is 0, this is 4x, this is 2. Okay, yes. So we need to multiply the brackets. Now this will be 4x square plus x plus 8x plus 2. That is equal to x cube plus 4x plus 2. 2 will get cancelled out, right? 2 will get cancelled out. So what we are left with is we can just take this to the right hand side. So we are left with x cube. So this is 4x and this is 8x plus 1 x, that is 9x. So 4x minus 9x will give us 5x. So minus 5x, okay, because 4x minus 9x, it will give us minus the 5x. Okay, and we are also left with 4x square. So how we should represent this as x cube minus 4x square minus 5x is equal to 0. We can just cancel x because x can't be 0, right? It is a base, so it can't be 0. We can just eliminate x from here. So what we are left with is x square, because we have just cancelled out x. So minus 4x minus 5 is equal to 0. So this is a basic quadratic question. I think you can just solve it. You need to just split the middle term. That should be equal to the product of the extremes. Or also what you can do is you can just use the formula, that is minus b plus minus under root b square minus 4ac upon 2a. Okay, that is minus b plus minus under root. Okay, what is happening here, bro? Minus b plus minus under root b square, that is minus 4 square, minus 4 into a, that is 1, c is minus 5 divided by 2a. A is of course 1. So this will be 4 plus minus, this is 16 and 5 into 4 is 20 and minus will be plus 1. So 20 plus 16 will be 36. So root 36 divided by 2, that is 4 plus 6 divided by 2 or 4 minus 6 divided by 2. So it will be either 5 because 10 by 2 is 5 or minus 1 because 4 minus 6 is minus 2. Minus 2 divided by 2 is 1. So this will be minus 1. But again, because this is a base, so it can't be negative. The only possible case will be x will be equal to 5 and not this. So now what we need to calculate is, because we know the value of base is 5, so we can do the remaining calculation here now. Okay. So now we need to find the value of this number in base decimal system, that is base 10. So 1, 2, 3, 4, that is in base 5. We need to find the value in base 10. So we need to find base 10 representation of this value. So how we used to do it? This 4 multiplied by 5 raised to power 0 plus 3 multiplied by 5 raised to power 1 plus 2 multiplied by 5 raised to power 2, and the last term also 1 multiplied by 5 raised to power 3. Okay, so this will be 125. 5 cube is 125 plus 5 square is 5 raised to power 2 is 25. 25 into 2 is 50. 5 into 3 is 15, and this is 4. 5 raised to power 0 is 1, so it is 4. So this will come out to be 125 plus 50 is 175. 175 plus 15 is 190. 190 plus 4 is 194. The answer for this question will be 194. That is option number B. I guess someone answered this question. Yeah. So Trends, your answer is correct. Answer for this question is 194. Okay. I think this should be clear now. If you have any doubts, you can just put it in the chat box. Regarding any question, if you want to ask anything, you can just put in the live chat. Moving ahead to the next question. Yeah, you need to find the unit digit of this term. So try this question. Okay, yes, you can try this question now. Okay, the time is up. Let's try to solve this question now. Like I told you, for the unit digit, if we have to calculate the unit digit of this number, that is 22 raised to the power 23 raised to power 24 raised to power 25 and so on. So we just need to divide the power by 4, and whatever the remainder is, we can just calculate the power of this number raised to that remainder, like we did, right? Let's say I had to calculate, if a number is 2, I had to calculate the unit digit of maybe raised to power 19. So what I did was, I can just divide this number by 4, and since the remainder is 3, because 4 into 4 is 16, the remainder is 3, so we can just calculate 2 raised to power 3, that is 8, right? So this is what we discussed. So we can apply the same logic here also. We need to divide this. So dividing it here, 23 raised to power 24 raised to power 25 divided by 4, and we need to check the remainder. See, again, the concept of negative remainder will help us, because 4 into 5 is 20, so the remainder can be either 3 or -1, and also we know that the power is 24 raised to some power, so this will be even number. So what we can write it here is that either 3 or -1, but we know that on writing -1, we will be able to do a small in small calculations, right? For example, -1, we can write the remainder as -1 raised to some even power. The calculation will not be that heavy if you will take the negative remainder raised to power 4, divided by 4. So this will come out to be, because -1 raised to even power will give me positive remainder, that is 1. So what I need to do is just need to check the 1 power of this number. So of course 2 raised to power 1 will give me 2. So this was a pretty doable question, I think, with the help of this logic, that I just need to divide the power by 4, and I just need to check the remainder, and I need to multiply whatever the remainder is. I just need to check that remainder raised to this power of the unit digit of this number. I think this should be also be pretty much clear. I use just the example whatever I have discussed in this class. So if you have any doubts, you can just ask in the chat box. Otherwise, we'll move to the next question. Okay. If you have any doubts, you can just put it in the chat box. There's one more question. This is on the okay base system again. So this question is also on base system. So try this question. Base 11 and base 19. Okay. Try this. You have 90 seconds time. You can try this question. Okay. Yes. Ara, your question. Your answer is correct. For the last question, it is 2. You can try this question also. Okay, the time is up. Let's start to do this question. So xy is a 2-digit number in base 11 such that both x and y are less than 11. It is 1/3 of the number formed by reversing the digits when considered in base 19. Okay, so the number xy written in base 11 is same as number yx written in base 19, right? So how do we represent these numbers in the decimal system, that is base 10? That is y multiplied by 11 raised to the power 0 plus x multiplied by cos x multiplied by 11 raised to the power 1. Okay. And the right hand side is x multiplied by 19 raised to the power 0 plus y multiplied by 19 raised to the power 1. Right. So we just need to equate these two equation on the two sides. So this is 11 into x plus y. I think I'm missing something. Yes, it is 1/3 of the number formed by reversing its digits. So this number is 1/3, right? So this is 1 by 3. So 19y plus x. We can just cross multiply 3 here. 33x plus 3y is equal to 19y plus x. Okay, you can just send x to the left hand side. It will be equal to 32x, and in the right hand side it will be 19 minus 3, that is 16y. So just writing it here, x divided by y will be equal to 16 divided by 32, that is 16 divided by 32, that is 1 by 2. So we are asked to find how many such numbers are possible. So we know the ratio of x and y is 1:2. So what we can write the numbers as 1 and 2, right? In the place of x I can write 1, in the place of y I can write 2. Same way I can write 2 here, 4 here, just the multiples, right? So it can be 1 and 2 because we have found the ratio. So if x is 1, y is 2. If we multiply 2 in the numerator as well as denominator, x will be 2, y will be 4, and so on we can multiply. So this will be 3 and 6, right? 4 and 8, and 5 and 10 also. 6, 12. See, because this number is in base 11, so we can't take this values and further values also, right? But we can still represent 10, because in base 10, sorry, in base 11 we can write the digits, we can take the, well, 10 is a single digit number in base 11, so we will consider this case, but we will not consider this case because the digits cannot be greater than the base. Okay, so 12 won't be considered. So the possible values will be these 5 values, that is x can be 1, y can be 2, x can be 2, y can be 4, and so on. X can be 5 and y can be 10. So these 5 cases will be possible. So how many such numbers are possible? So 5 numbers will be possible. Okay, so I think you must have tried this question and the answer is 5. You can just check your answer. I hope this should also be clear. If you have any doubts, you can just ask in the chat box. Moving ahead, one more question from the remainders. Try this. Okay, so you have 90 seconds time. Try this question. Let me see if you have any doubts. Okay, so the time is up. Let's attempt this question. In this question, we are asked that a number leaves a remainder of 51 when divided by 323. So we don't know the number, right? So let's say the number is n divided by 323. The remainder is 51. Yes. Now we need to calculate the remainder when the same number is divided by 19. Like I told you, we can represent this number as 323 multiplied with some constant plus 51, right? So the n can be represented as 323 multiplied with some constant plus 51. So this is the this way we can represent the number. Now we need to find the remainder when this number is divided by 19. Okay, so 323, here case you can say some constant or the quotient also. So multiplied with by 51, sorry, added 51, and we need to find the remainder when this particular term, that is n, is divided by 19. Okay, so because we know that 323 is divisible by 19, so this value will not depend on the value of k. Whatever value you put in the place of k, because 323 is completely divisible by 19, so here the remainder will be 0. This will be, sorry, because it is completely dividing it, so the remainder will be 0 from here, right? So we just need to calculate the remainder from 51. So 51 divided by 19 will give me, so 38 will be completely divisible, 19 into 2. So 51 minus 38 will be 13. Okay, so 323, because it is a factor of 19, so it multiple of 19, so it will be completely divisible. So we need to just check the remainder from the second term, that is 51. So 0 plus 13 is 13. So this will be the final remainder. That will be option number C. So if let's say this number was not divisible by 19, then the value will depend upon the constant k. So in that case, the answer could have been cannot be determined. But here, because 323 is divisible by 19, so whatever value you put in place of k, it will be completely divisible. So we just need to see the remainder with the second term, that is 51. So 51 divided by 19, we need to check the remainder. So the remainder is 13 because 19 into 2 is 38. So 51 minus 38 is 13. So I hope this should also be pretty much clear. If you have any doubts, you can just ask in the chat. Otherwise, we will move to the next question, that is question number 7. Yeah, answers are correct for trends and RRG9X. So your answers are correct. Try to do this question. This question is also from base system. Okay. 90 seconds should be sufficient for this question. Try to attempt this question. Okay, let's attempt this question. I guess yes, the timer is about to end. Let's try to attempt this question. So again, we don't know the value of x. We don't know the value of b, that is base. We need to calculate the value of b. Okay. So we are given that x is written 3 times. That is, this is the number. This is written in base b. This is equal to x cube. Okay. So we need to find the value of b. So what I can do here is, I can write, because I know the base is b. So how I will represent this number? This is b raised to power 0 multiplied by x plus b raised to the power 1 multiplied by x. Same here, also b raised to power 2 multiplied by x. That is equal to x cube. Okay, so this is what best I can do. So this is b square plus bx plus x, that is equal to x cube. X cube. Again, we can just cancel out x because it is not 0. So this is b square plus b plus 1, that is equal to x square. Okay, even though we cannot solve it further, but from this equation you can note here is that because both x and b are whole numbers, but not whole numbers, they are not 0, so they are natural numbers, and we are adding some value to b square, then it is getting equal to x square. So from this particular equation, what we can derive is that b square should be less than x square, right? So because these are natural numbers and we are adding some value to b square and then it is getting equal to x square, so essentially b square is less than x square, right? Then only we can add something to b square and it will get equal to x square. So we can just take the square root. So this will come out to be b is less than x. Okay, but yes, if b is less than x, so the base is less than x. So this will violate the condition. So we are given that x is written 3 times under base b. So the basic condition of base is that these digits should be less than the base. So if, for example, if the base is 5, so whatever digit I will write here will be 4 or less, right? It should not be equal to 5 or more than 5. So, and this condition is telling me that x is greater than base. That is, this x is greater than base. So if I take here, let's say I'm taking the value of x, I'm taking, let's say 6. This is 6. Then x is greater than base. So this can be 5 or maybe less than 5, but this is not possible, right? Because the base is 5, so the values that I can write, the digits that I can write should be less than 5. So I think this is violating the condition, so this is not possible. So it will be E, none of the above, and the answer will be it is not possible, right? So this was a good question from base system. If you have any doubts regarding this question, you can just ask in the chat box. Okay, I don't think you have any doubt, otherwise you can just put it in the chat box. Yeah, okay, so that was the last question for the day. So this is about the free mock test that I already told you in the beginning of the session, that we are providing 5 free mock tests. So if you are preparing for IIM Bangalore UG UG entrance test, so you can just visit the website, that is cracku.in/IIM Bangalore UG mock test. These are free 5 mock tests that we are providing. You can just register on the website and you will be able to give those tests for free. Okay, so apart from this, I think there's one more update. Yes, this is about WhatsApp channel. So I have already informed you that you can just go to the description of this video. You will be able to find the link of the WhatsApp channel. All the free preparation resources and important updates will be shared on that particular WhatsApp channel. Okay, so that was it about this session. So I hope this was useful for you. After this session also, if you have any doubts regarding any question, you can just put it in the comment section and I will reply to that comment section. Okay. So thanks for joining.